Okay, now we're going to look at how to set up a hypothesis test. So we talked about what it is to do a hypothesis test. Now we're going to look at how to set up those two claims. Claim 1, the null hypothesis, and claim 2, the alternative hypothesis. So when we do a hypothesis test, we're able to test for 3 parameters. Mu, which remember is the population mean. P, which is the population proportion, and proportion is a fancy word for percentage, and sigma, and that's the population standard deviation. We are going to focus mainly on, well, only actually on the proportions and the means. We are not going to look at how to do the hypothesis test on the population standard deviation. And actually, you can do hypothesis tests on other values. These are the 3 most common ones. But we're only going to look at the mean and the proportion. But just know that there are ways to do tests on the standard deviation as well. So there are 3 possible setups for a hypothesis test. We're going to look at an example where we are testing the mean. So I am saying, okay, I think that the mean age of a college student is not 18, or let's say 20, okay? I found some number out there that said college students are 20 years old on average. Because you start at 18, it's supposed to take you 4 years. 18 to 22, that's the range, so the mean would be 20. And I think that's hooey, because I work in a community college, and I have students of all different ages. So there are 3 different ways that I could set up this hypothesis test to say, no, that doesn't sound right. The first way is to create what's called a right-tailed test. So the null hypothesis in a right-tailed test, we start with our HO. Ooh, I don't know what is happening with my pen right now. So we start with our HO saying, hey, this is my null hypothesis. This is my status quo hypothesis. This is what I'm assuming is true. And then we have whatever the parameter is that we're testing. So we are testing the mean. And then we're always going to assume that it's equal to some number. This mu not here means some number. And in this case, I would be saying that the mean is the mean age, and I'm going to start out by assuming that that mean age is equal to 20, because that's what this paper found. They said the average age of a college student is 20. And I looked at that and said, I don't think so. So that's what I would start with for my null hypothesis. I'm assuming that's true because that's what this paper told me was true. The alternative hypothesis, however, remember that's what I think is actually happening. So with a right-tailed test, your alternative hypothesis, again, we have HA, so the A stands for alternative. We're still looking at the mean, and then I'm saying that the mean is greater than whatever I was reported for that value. So this again is a number for this mu with the little 0 next to it, and it's going to be the same number that I used in the null. Same number as the null. So if this were a right-tailed test in words, this says the mean age is assumed to be equal to 20. But the alternative, what I think is happening, is that the mean age is greater than 20. That's what the right-tailed test would be for this example that I'm using. That's one possible way to set up a test. And it's whenever you think or the researcher thinks that the mean or the proportion is greater than or more than or any of those keywords that we've seen that indicate greater than. The second way to set up this test is as a left-tailed test. Now, the null hypothesis on a left-tailed test is going to look pretty much the same as it did on the right-tailed test. You have your H naught, which indicates that this is the null hypothesis. You have the parameter value that you're testing, so either mu if it's a mean or p if it's a proportion. We always assume that it's equal to. And then whatever the number is that we are being told that it's equal to. And this is going to be told to us through prior research, through census data, through an article that we read, through something like that. Okay, it might be some threshold value that we're trying to stay over or under, if it's medical research, something like that. So again, in this example that I'm using, I'm saying that the mean age is equal to 20 because that's what I read in this paper. And that's the number that I disagree with. But then the left-tailed test, the alternative, HA, I'm still looking at a mean, but now I think the mean is less than that number from the article that I read, which was 20. So a right-tailed test is when you think the value is greater than. A left-tailed test is when you think the value is less than. And if you think about when we were drawing normal curves, because hypothesis tests are going to be normally distributed data, if we had a greater than function, we shaded everything that was to the right. If we had a less than, we shaded everything to the left. So it's continuing that to the right, to the left kind of thinking. And then the last thing, or the last way to set this up, is a two-tailed test. And this one's a little bit funky as far as how we think about it. So our null hypothesis is the same. Notice there's really no difference in how I set up my null hypothesis. HO indicates that this is my null. I'm looking at the mean age. I'm saying that that's equal to, and then I read an article saying that that was going to be equal to 20. But then my alternative, HA, I'm saying that the mean is not equal to or just different from that value of 20. So this would be a case where I don't know if the mean age is more than 20 or less than 20. Because I might look at this and say, well, you know, I have had some high schoolers in my classes. I have had students that are in high school, but they're taking college classes with me so that they can get college credits. So maybe they're messing that up. I still don't think it's 20 though. 20 just doesn't sound right to me. So this is where you could do a two-tailed test. You don't know if it's less than or greater than. All you know is that 20 is not the right number. So you set it up as a two-tailed test, not equal to. And when we get into the actual examples, I will show you what it means with this two-tailed, how that is calculated. So let's look at a couple of examples and look at how we would set this up with some different scenarios presented to us as different word problems. So the first example says The mean annual rainfall in Arizona is 8 inches per year historically. However, weather researchers are interested in whether this amount of rain has decreased in recent years, leading to drought conditions in the state. Write a null and alternative hypothesis for this situation. So what's interesting to me, what I need to pick out from this problem, is the fact that we're looking at the mean annual rainfall. So the word mean here is important because I need to know whether I'm doing a test on a mean, a proportion, or a standard deviation. It is 8 inches per year historically. That's important to me. That's going to give me kind of this status quo number. Okay, historical information, census data, that kind of stuff, that gives you that status quo information to use for your null hypothesis. And then the weather researchers are interested in whether this amount has decreased in recent years. That's what they're interested in. They want to know, is the amount of rain going down? Are we getting less rain? And now that means we're in a drought, which changes everything about how you use water as a state. So to write out this null and alternative, you're going to write your null by starting with HO. And then if we're looking at the mean annual rainfall, then the parameter that we're testing is mu. Your null is always going to be equal to, and then it's going to be equal to whatever you were presented with as the historical information. So we're going to assume that we are still getting 8 inches of rain each year in Arizona. That's what we're going to start out assuming. But these researchers want to test their alternative, HA, and see if the mean, mu, is decreasing. So going down, if it's becoming less than 8 inches. And that's how you set up this first problem. So I'm looking at the mean. I look at how much it was in the past or how much I was told it was. And then what do the researchers think is happening? So let's look at the second one. The Kelley Blue Book value or price of a used Chevy Corvette is $86,012. Grant wonders if the mean price of a used Chevy Corvette in the Denver area is different than $86,012. So now for this one, let's see. So I've been presented with a number for the price of a Chevy Corvette. And then Grant is looking at the mean price. So again, here's this word mean. And then he wants to know, is it different than what's being reported by Kelley Blue Book? So I have a reported price from Kelley Blue Book. That price is the mean. And then Grant wants to know, is the price actually different from that? So the null hypothesis would be mu because it's a mean. We're always going to assume that it's equal to, and then $86,012 because that's what Kelley Blue Book is telling us the price should be. And then the alternative, which is HA, would be still mu. But then Grant thinks that it's different, so he doesn't know whether it's more than or less than. So that's going to be the not equal to symbol. And then 86,012. And then the last one, the Medco Pharmaceutical Company has just developed a new antibiotic for children. 2% of children taking competing antibiotics experience headaches as a side effect. A researcher for the FDA wants to know if the percentage of children taking the new antibiotic who experience headaches as a side effect is more than 2%. So now here, let's see, we have a new antibiotic. 2% of children on a competing antibiotic are experiencing headaches. That might be important, 2%. It's written out in words, but it's still a number, 2%. A researcher for the FDA wants to know if the percentage of children taking the new antibiotic who experience headaches as a side effect is more than 2%. So now I don't have a word in here to jump out at me like mean, proportion, standard deviation. But remember, the word proportion is kind of a fancy word for percent. It's not identically a word for percent. They're not exactly the same word, but they're very similar. So if you see percentages, then that should hopefully indicate to you, hey, this might be proportions. Okay? So we're going to set up our null and our alternative hypotheses. So our null starts with our HO. The parameter that we're testing now is not mu, it is P, because if we come back up here, we're testing for the parameter, the population proportion is P. So I want to know, is the population proportion of children receiving headaches? Well, on the other antibiotic, it's equal to 2%, and I'm going to write that as a decimal. And now they have this new medication that they want to test. So they're testing their new medication in their alternative. And they want to know, is the proportion going to be more than 0.02 or 2%? Because if it's more than 2%, parents aren't going to want their kids to get this new medication. Doctors aren't going to prescribe it because they know that this other antibiotic isn't going to give as many kids headaches. So they want to make sure that they're not going to give more kids headaches. So that's what they're going to check and make sure. Are we giving more kids headaches? If the answer is yes, then they're probably going to want to go back and reformulate their antibiotic somehow, if they can. If the answer is no, then they'll probably go ahead and put it out on the market. So this is how you set up that first step, the claims to your hypothesis test. And it's very important that you do this step before you go out and gather data and do any of that. Because if you gather data and then you look at your data, that can skew your alternative. And you need to establish these alternatives before you gather data. So this is the first step to the large process of how to do a hypothesis test. And yeah.